Okay, so I want to just kind of run through a little bit more, one more model problem of what linear programming looks like, and then we're going to jump into one new topic, and then we'll be done with our unit, and then tomorrow we'll just kind of review and take our assessment. I know that the linear programming problems we've seen so far are a little bit like far-fetched and a little bit weird, and like, oh, you're making bowls and mugs, and you don't even know how to sculpt any clay. But the reality is that we can use these things to kind of model some, or sort of use the idea to show how we could use this math, even if we don't have all the details about the certain relationships that we might have. So here's sort of my most realistic example of how we might be able to use this. And so obviously, like, the relationships or the numbers that we might use to explain how much it costs to do certain political advertisements or whatever, these might be different numbers, but the reality is this is something that people think about. How can I get the most amount of, like, donations out of the advertisements that I send for my political campaign, for example? So here's my example for today. We are running a political campaign. You can choose your preferred candidate, and we'll just go with that. We're going to try to make Facebook ads and TV ads. Those are two of the kind of most prominent ads that we see right now for political office, and so I want to kind of reflect that. So let's say that a 30-second TV ad nationally costs that much money. Let's say that a Facebook ad costs this much money. Okay. Total, let's say that we have $4 million to run advertisements. And that's kind of like, I mean, realistically, how much money do political campaigns really run, spend on advertisements? It's a lot. We also know that, like, there are so many different people in the world, in the country. And so our goal is to run a bunch of different types of advertisements to make sure we kind of attract all of these different types of people with our advertisements. So we want to try to have 50 ads at least. Um, and then we have some data that we've done some research about, and we see, okay, we think that we're going to get $100,000 in donations every time we run a TV ad, and we think we're going to get $85,000 in donations for every Facebook ad we run. Now, obviously, these numbers might not be right, but we can just say, okay, now that I have real information, this is what we could do with it. So our goal is to figure out how much money should we put into, or how many TV ads, how many Facebook ads should we run, and then how much money would we expect to make. Okay, so let's start with the money that we have. It said that we would be spending $125,000 for every TV ad. So I'm going to write T for TV. And then we said that for every Facebook ad, that would be $50,000. So 50,000. And then I'm going to use the capital F. Hopefully that T and that F look different enough, but I'll make sure that we're color coding everything. We have, if we add those two together, we have to be less than or equal to 4 million, because that's the money that we have to spend. Between the TV ads and the Facebook ads, together, if you count them up, we want to be greater than or equal to 50, because we want to have a bunch of different types of ads. And then the reality is, okay, you can't run a negative number of ads, either kind. So T has to be greater than or equal to 0, and F has to be greater than or equal to 0. Our objective function is about how many donations we're going to get. So we think we're going to get $100,000 for every TV ad, plus $85,000 for every Facebook ad. This is my objective function. This is my profit function, because this is about how much money I'm going to make. So my profit is equal to this. The next step on these types of problems is we have to graph those inequalities. And so I just wrote here, you know what, I'm going to call T my x variable and f my y variable. You can pick it either way and it doesn't really matter, but it just makes it easier and it makes me more comfortable like graphing these inequalities. So here they are rewritten as x's and y's. Oops, I made one mistake really quick. So I got to change this one to an x. Okay. Now I need to solve all these inequalities for y so that I can graph them. The only really challenging one is this one, so I'm going to save this one for a second. This one, I'm just going to subtract x from both sides, so then I'll get y is greater than or equal to 50 minus x. And then this one will go over here for a second just to have a little more space. So I'm going to subtract 125,000x from both sides, so I get 50,000 y is less than or equal to 4 million minus 125,000 x. I know that's a lot of zeros, but now when I divide by both sides by 50,000, a lot of those zeros are going to go away. Just a reminder, when you do this division on this side, make sure that you do the 4 million divided by 50,000, and then do the negative 125,000 divided by 50,000. Just be careful there. So over here I get y is less than or equal to 80 minus 2.5x. Just really quickly for my own, so that it's easier for me to graph, I know that the decimal 2.5 is the same as 5 over 2. So let's do these graphing. Let's do graphing now. So let's see. We have 80 minus 2.5x. So 80 is my y-intercept. I want to do that in blue. 80. And then my slope is negative 5 over 2, so I can count 1, 2, 3, 4, 5, 1, 2. This works as long as your x scale and y scale are the same. So it is in this graph, so we can just kind of go like this. So not this spot. And then we continue our line down. Right there. Okay. This is a solid line because I have or equal to. So then that line looks like that. And then the other one is this one. So y is greater than 50 minus x. So 50 is here. Slope is negative 1. Again, this is going to be a solid line because it's or equal to. So that looks like that. My non-negativity constraints just say, okay, this thing has to be greater than or equal to 0, both the y and the x. So my feasible region is going to be this area in here. That spot right there. So I can see most of my points. There's going to be one that I actually have to calculate a little bit. So this point is the point 50, sorry, not 50, 0, 50. This is the point 0, 0. This is the point, I don't know that one yet. And then this is the point 20, 30. So I need to figure out what this point is. And the way that I'm going to do that is I'm going to put in 0 for y right here, and then I'm going to solve for x. The reason I can do that is because the y value here has to be something, 0. So the y value is 0 because it's on the x-axis. So then I can put in 0 equals 80 minus 2.5x. So this is a quick two-step equation. And negative 80 divided by negative 2.5 is x is 32. Okay, so this is the point 32, 0. Now I can go back to this spot and test the vertices of my feasible region in the objective function. My objective function is 100,000 x plus 85,000 y. Remember, I'm changing my t's for x's and my f's for y's. So then I'm going to write in those points. We had 0, 0. We had 32, 0. We had 20, 30. And then we had 0, 50. So I'm just going to put those numbers in. I'm going to get 0 for this one, so that's not so good. I'm going to get 3,200,000 for that one. For the next one, I'm going to put my 20 in and my 30 in. I'm actually going to write that one out. So, excuse me, 100,000, 20 plus 85,000 times 30. And that one gives me $4,550,000. These are all in dollars. And then the last one is 85,000 times 50. What do I get? 4,250,000. Okay, so the winner here is the one that we make the most amount of money on, and that is the plan where we have 20 TV ads and 30 Facebook ads. So be prepared to see a problem like this on the assessment. This one might not be exactly the same. It might not be political ads, but it might be something like the bowls and mugs that we saw earlier. It might be some other kind of example. So your steps are write those constraints, graph the constraints, test the objective function. Those three things. I'm going to recommend that you kind of take a little bit of a stretch break here because we're going to jump into a new set of types of problems, and they just kind of take a long time. The steps aren't super difficult and the steps aren't new really. It's just that there are sort of some new things that you have to do, and it just takes kind of a longer time. So take a stretch break and come back to the video. Okay. We are going to work on the second part of learning target 3A, and I know that we had started with 3A at the very beginning of this unit, but we're going to finish it today. We're going to work on solving systems of equations in 3 variables using algebraic strategies, and this is still going to be sort of substitution and elimination, but this time we're going to have x's, y's, and z's. All right, so we have an x and a y and a z in this equation, which means we need to get the system. So that means we need to get our answer to look like a coordinate point, which is x, comma, y, comma, z. We call this an ordered triple, if you're fancy. Okay, so the first thing that we need to do is we're going to use elimination because we need to try to eliminate. Step 1 is to eliminate one variable, but we need to do it 2 different ways. And when I say that, I mean we're going to use 2 equations at a time, but we're going to choose 2 different pairs of equations. So here we go. I'm going to start by labeling these equations because I want to call them specific things so that we know what we're talking about. So let's call this equation equation 1, this is equation 2, and this is equation 3. So I'm going to start by eliminating the x's, and I see that just because it kind of looks like it's going to be pretty easy to do that. So I'm going to take equation 1 and add it to equation 2. And the reason I can do that is because Just like with regular elimination, I can look at this and see, oh, there's a negative x and a positive x, and I can see if I add those two together, I will get 0. So, so let's do that. So let's rewrite negative x minus 2y minus 2z equals negative 14. And then x minus 5y plus 3z equals negative 17. So then when I add those, I get no x's, but I get negative 7y, and then I get z, and then I get negative 31. Okay, so I have one equation where I eliminated x one way. Because I used equations 1 and 2 the first time, I can't use those same two equations again. So this time, instead of using 1 and 2, I'm going to use 1 and 3. But this time, to eliminate an x, I need to take my equation number 1 and multiply it by 2, and then add it to equation 3. So I'll show you what that looks like. So equation 1 times 2 would be negative 2x minus 4y minus 4z equals negative 28. And then what I get when I do equation 3, I just rewrite it. So I get 2x minus 2y plus 6z equals 6. When I add these together, again, my x's are going to add to 0, and I end up with negative 6y plus 2z equals negative 22 this time. So if I look really carefully at what I have created, I now have this and this. Step 2 is to take those two things that I just highlighted and solve the system of two equations and two unknowns. And that's the stuff that's highlighted. So that's this system. Negative 7y plus z equals negative 31, and negative 6y plus 2z equals negative 22. I'm actually going to go ahead and do that right here, and I actually think that the best way to do this is to do substitution. Now, you might be like, no, just eliminate, but either way will work. So what I'm going to do is I'm going to take the first equation and I'm going to add 7y to both sides. So I'll get z equals negative 31 plus 7y. Then I'm going to take that information and substitute it into the other equation where I see my z. So I'm going to rewrite, so I get negative 6y plus 2 times negative 31 plus 7y equals negative 22. Distribute and combine like terms, so I get negative 6y plus, I'll say minus 62 plus 14y equals negative 22. Combine my like terms, and I have 8y minus 62 equals negative 22. Add 62 to both sides, and I get 8y equals 40. Divide both sides by 8, and I get y is 5. Yay. Okay, so now I have an answer. So remember that my answer is supposed to look like x, y, z, but I do have y is 5, which is good. That's progress. Now I can take my y is 5 and put that back up into either one of these equations. Because this one's already solved for z, I can just use it right there. So z is 31 plus 7y. Okay. Just kidding, it's negative 31. Okay, so I'm going to take that 5 and put it in here. So I get negative 31. Why is it highlighted? negative 31 plus 7 times 5. 7 times 5 is 35, so I get negative 31 plus 35. So z is 4. That seems like I'm making progress, so then let's record that. Step 3 of this whole process is to take the two pieces of information that I just got and use those to solve for the last variable. Now, it shouldn't really matter which equation you use to put y is 5 and z is 4 in. Just make sure you use one of the first original 3. So let's take the first one, because what the heck, why not? So negative x minus 2, but I'm not going to write y, I'm going to write 5. Minus 2, but I'm not going to write z, I'm going to write 4. And then I get is equal to negative 14. So then I have to solve. So this is going to be negative x minus 10 minus 8 equals negative 14. So I get negative x minus 18 is negative 14. Add 18, I get negative x is equal to 4. Divide both sides by negative 1. I get x is negative 4. Hey, another answer. So my last answer is x is negative 4 here. My goal is to rewrite my answer as x, y, z, so I have to write it in that order. So my answer is negative 4, 5, 4. There it is. I'm going to zoom out a little bit so that you can see the whole process here. I know that there's a lot of stuff on this slide. There are really just 3 steps that I did. I know that I did a lot of stuff here, but the first one is to eliminate one variable 2 different ways. The second step is to solve the system that you create after you do that. And then the third step is to use those solutions to solve for the last variable. Okay, so I am going to do one more of these. I know that these are kind of long, and I know that this one slide was like 9 minutes, but I think it's important that you see one more example before you do a little practice. This time my steps are even written in text, so that's how you know it's real. Just kidding. I'm going to again kind of start with labeling my equations, because that's helpful for me to organize my thinking. I'm going to look really quickly, what is the variable that seems like it's going to be the easiest to eliminate? And I'm looking at these z's. Because look, I got 2 z's and negative 2 z's. I could just add those 2 equations. The other thing I see is I could take this equation, multiply it by 2, and add it to this equation and eliminate the z's again. So just think like, what is the easiest way you can actually eliminate one of the variables 2 different ways? So you can kind of make that quick decision at the beginning of the problem. This is sort of a choose your own adventure, and I recognize that sometimes the adventure you choose is a little bit less fun than the other ones. I've been sort of choosing my own adventure as I'm writing how I'm doing these problems today, and I'm noticing sometimes it just doesn't really work that well. So if you feel like, oh, this is just not going well, and I feel like I just keep getting bigger and bigger numbers or something else is going weird, you can always try a different strategy. So you can always try a different variable to try to eliminate at the beginning. But let's see what happens when we do this. So step 1 is we're going to eliminate z. So I said, let's take equation 2 and add it to equation 3. The other thing I said was to do, okay, let's take 2 times equation 1 and add it to equation 2. So that's just to keep me honest, to make sure that that's what I do. Let's do it. So equation 2 plus equation 3, I'm just going to write it right underneath here because I have space and because it's just like, I just have to follow everything down. So I get 5x, and then I get 8y, and then I get no z's, but I get 38 over here. I know I'm going to use that later, so I'm going to highlight it in green to keep myself thinking like, oh, that's the thing that I'm trying to do. Okay, next step is to take 2 times equation 1, which was 2x minus 10y plus 2z equals negative 60, and add that to 3x plus 6y minus 2z equals 26. Okay, so I get 5x minus 4y plus 0z's equals 34. Check my work. I would tell you that I was testing you, but really I just made a mistake. Okay, so then that should be a negative. So then here's my other equation that I'm using. All right, so step 2 is to solve that system. So step 2 is the system 5x plus 8y equals 38, and then 5x plus minus 4y is negative 34. Hey, let's take one of those equations and multiply it by negative 1, because then I can get rid of those x's. You might have a different plan about how to eliminate, or maybe you're going to use substitution. It doesn't really matter. Both methods should work, but this is the thing that I saw right away, so I'm just going to do it. Negative 5x minus 8y equals negative 38. And then rewrite 5x minus 4y equals negative 34. I get no x's, but I get negative 12y's, and then I get negative 72. Okay, so then let's divide both sides by negative 12, and I get y is 6. Things are looking pretty good so far. Okay, now let's take our 6 and put it back in. Doesn't matter which equation you use. Let's rewrite. Okay, so what am I doing? All right, 5x minus 24 equals negative 34. Let's add 24. I get 5x is negative 10. Divide both sides by 5, divide both sides by 5. X should be negative 2. Again, things are looking good here. I'm starting to see my answer. I have x and I have y. Now I just have to get z. So step 3 is to take what I know from steps 1 and 2 and rewrite to get z. So I have x is negative 2. Let's use the first equation. So negative 2 minus 5 times 6 plus z equals negative 30. Okay, I used the equation way up here at the very top, equation 1. I put in my negative 2 for x, and I put in my 6 for z. Then I have to solve, for y. Then I have to solve for z. So let's combine like terms. 5 times 6 is 30. So negative 2 minus 30 is negative 32. Plus z equals negative 30. Add 32. Add 32. I get z is 2. That's nice. Okay, so now let's rewrite our equation or our answer in x, comma y, comma z. So my answer is negative 2, 6, 2. There it is. Okay, one more practice problem is on this video. I'm going to put it here. Okay, surprise, I'm back. Let's take 2 times equation 2, add it to equation 1. Like that. Okay, cool. Next way I'm going to eliminate y is I'm going to take 2 times equation 3 and add that to 1. Just kidding, it's 72. Okay, what I have here is this and this. Oh, check this out. This is sweet. If you take this equation and just add it to this equation, that eliminates the x's and I get a z answer right away. So I get negative 14z equals negative 70. Divide both sides by negative 14, and I get z is 5. Let's take that and put it back in here. Rewrite 8x minus 6 times 5 is 2. Okay, 8x minus 30 is 2. Add 30. I get 8x equals 32. So x is 4. Things are going well. So then I have x and z. Let's find out what y is. I'm going to take equation 2 this time just to shake things up because I'm cool. Okay, so x is 4. So 6 times 4 minus y. That's what I need to find out. Minus 4 times 5 is 7. Okay, combine like terms. I get 24 minus y minus 20 equals 7. Okay, so then 24 minus 20 is 4, so 4 minus y equals 7. Subtract 4, I get negative y equals 3, so y is negative 3. Okay, my answer is the point 4, negative 3, 5. There it is. Well, that was like a really, really long video. I'm very sorry about how long that video ended up. You have a little bit of practice. Tomorrow we will just do a little review and then an assessment. So if you take a little bit extra time on this assignment, it's no big deal. You have an assessment coming up tomorrow. Nice work today. Thanks for your extra effort on watching this video. Thanks for your patience.